Okay, so welcome to our lectures. We are continuing from where we left off. Okay, we are looking at understanding defense. So this is where we left off: security policies, regulations, and standards. So this is what we were supposed to cover yesterday, but unfortunately I had an issue, which I did explain to you guys. Okay, so the thing is, we are going to continue with the lectures, meaning that come Monday, we have to do hands-on labs. Okay, so business policies, these are just guidelines that are developed by an organization to govern its actions. Okay, so the policies, they do define standards of correct behavior for the business and its employees. Okay, in networking policies, they normally define the activities that are allowed on the network. Okay, so this sets a baseline of acceptable use. That is how people are supposed to use the company network. So we find that an organization can have several guiding policies, and these are the policies that have been listed here. So we have company policies. Okay, so these, they have to create the rules of conduct and responsibilities of both the employees and employers. Okay, so these same company policies, they do protect the rights of workers as well as the interests of the employers. Then we have employee policies. Okay, so these policies are created and maintained by the human resource staff. So they've got to do with the salary of workers, the pay schedule, employees' benefits, work schedule, vacations, and so on. And then the organization also must have the security policies. So these policies, they do define a set of security objectives for a company. Okay, they define the rules of behavior for users and administrators. Okay, also they do specify system requirements. So this document is very, very important in the organization. So the organization must have a security policy. Okay, so this is a document. All right, so it is in the same document whereby, when we look at, the same document can say we want a password to have at least 8 characters. Okay, now, what is written in this document has to be implemented by network technicians, okay, network admins. Okay, so this is very, very important. All right, so how should users behave and administrators? It is contained in the same document. There is no way that in this time and age, your organization, doesn't have this document. It means there's something wrong. Okay, so you see, these objectives, rules, and requirements collectively do ensure the security of a network and the computer systems in an organization. Okay, And of course, time and again, because things are changing, even the content of the security policy has to be changed. Okay. So this document, of course, it is used to inform users, staff, and managers of an organization's requirement for protecting technology and information assets. So this document, of course, has a number of benefits. It does demonstrate your organization's commitment to security. So if you don't have this document, it means your organization is not committed to security, which is really, really bad. Okay? Sets the rules for expected behavior, all right? How workers in organizations should behave. Ensures consistency in system operations, software and hardware acquisition and use and maintenance. You know, so this is whereby you can have computers from the same manufacturer, okay, having the same software from certain vendors running. And of course, these must be genuine vendors. So you can see how important this is. Okay. So in this same document, you can say that we won't allow a situation whereby workers will be installing their own software. Okay. You can do that. So that can be implemented by the network admin, whereby if a certain individual wants to install something, he won't, because the system will be protected. You know, okay? So definitely, when somebody wants to install the software, he will be requested for the password. If he doesn't have that password, then he won't be able to install. Okay? Define the legal consequences for violations. So this is very, very important. Give security staff the backing of management. Why? Because this document has to be approved by management. Okay. So a security policy also specifies the mechanisms that are needed to meet security requirements and provides a baseline from which to acquire, configure, and audit computer systems and networks for compliancy. Okay. All right. So this is what this document contains. Identification and authentication policies. Okay. So this specifies authorized persons that can have access to network resources, okay, and identity verification procedures. So the document can have also password policies, okay, acceptable user policy. So this one identifies network applications and uses that are acceptable to the organization, okay. Remote access policy, all right. So this one, it identifies how remote users can access a network and what is accessible via remote connectivity, okay. Network maintenance, how you should maintain the network. Incident handling procedures. So very, very important to have this. That is, if your organization has been hacked, very, very important that you follow a certain procedures, how you can handle the incident. Okay, so this is very, very important. Okay, bring your own device policies. So we now know that some people do come with their own devices at work. So very, very important that you have the BYOD policy. Okay. So this policy, of course, should specify the goals of the BYOD program, it should identify which workers can bring their own devices, which devices will be supported in your organization, okay? Also, identify the level of access workers are granted when they are using personal devices, okay? Describe the rights to access and activities permitted to security personnel on the device. So this is also a very, very important policy, during this time that we are living in. So what are some of the best practices associated with the BOID security? Okay. Those devices, of course, they need password protection. And you also have to manually control wireless connectivity. Why? Because of fake, Wi-Fi. Keep updated. It means, of course, the devices that you are using, your own devices, they have to be updated, okay? Backup data. And of course, you need to enable Find My Device in case you lose them. And when you lose a device with valuable information, then of course, that is really, really dangerous to your organization. Okay. Also provide antivirus software on those devices. Very, very important. We also have what is known as the mobile device management software. What is this? Okay. So this is a software which you can have, and also your organization must have the device which is going to be in charge of, MDM. So MDM, this is used when, of course, maybe you went on a vacation for 2 months, okay, and then you're coming back to the organization. So what is going to happen is that your organization, first of all, is going to be sent to the MDM. The MDM then will be able to check whether your system is up to date. If not, then your system will be updated. That is when your device will be allowed to connect to the network. Okay, all right. Then, of course, we have regulatory and standards compliancy. So when you are into security, very, very important that you have to familiarize yourself with laws and codes of ethics that are binding for you who are into security. Okay, so you can see here that many organizations are mandated to develop and implement these security policies. Okay, and then here in Zambia, anyway, we have the regulator, anyway, ZICTA. But in other developed countries, they have a number of compliance regulators. Okay, so these regulators, they come up with their own documents. That is, of course, in the US, we have HIPAA. We're going to look at that. So HIPAA normally deals with health information. So HIPAA comes up with the document which it gives to hospitals. That is how hospitals should handle the information of patients. Okay. Now, if this hospital do have a breach and HIPAA goes there and do investigate that this hospital didn't follow what HIPAA is recommending, then that hospital has to pay a fine. So this is very, very important. So HIPAA, of course, makes sure that health institutions do take care of the information of patients very, very well. So that's how regulators do work. Do you have questions on this slide, understanding defense? You know, very, very important, as I've been saying, that you have to ask. Okay, so do you have questions on module 18? If not, then we are going to continue. Okay, module 19 is access control. Okay, so the module objective here is to explain access control as a method of protecting a network. Okay, so we'll look at access control concepts, right? CIA triad, you know, CIA triad is related to information security. So information security, of course, deals with protecting information and information systems from unauthorized access, of course, use, disclosure, disruption, modification, or destruction. Okay, this is the definition of information security. So confidentiality deals with making sure that information is not disclosed to unauthorized users. Integrity, okay, so this makes sure that, you know, information hasn't been altered while in transit. Okay, so with confidentiality, I mean, what do we use to achieve confidentiality? We use encryption. And what is encryption? Encryption is when we pass information through mathematical formulas and that information becomes scrambled. That is, you can't read that information. Okay, you can only read that information if you have the decryption key. Okay, integrity. How do we achieve integrity? It is through a process called hashing. And what is hashing? Hashing is when, of course, we pass information through the hashing function, and what is going to be generated is a fixed value called a hash. Okay, and of course, you have seen on certain websites where you want to download a particular software, you find that they would put an MD5 hash or a SHA hash. Okay, so for example, we can have the hash value, let's say 1, 2, 3, 4, 5, 6. Okay, so when you download that software, these hash calculators, they are there for free. So you can also have the hash calculator on your laptop, and then you also run that software in that hash calculator. If you be able to generate the value 1, 2, 3, 4, 5, 6, it means that while you were downloading, that software was not altered. Okay, and then availability. This makes sure that the system is accessible. You are able to access information. Okay, availability. So we call that the CIA triad. Okay. We also have what is known as the zero trust security. So this zero trust, is a comprehensive approach to securing all access across networks, applications, and environments. Okay. So this approach helps secure access from users, end user devices, APIs, IoT, microservices, containers, and more. Okay, so the principle of the zero trust approach is never trust, but always you have to verify. Okay, so you see, the zero trust security framework helps to prevent unauthorized access, it also contained the breaches. You know, the breaches, this is when we have unauthorized disclosure of information and reduce the risks of an attack's lateral movement through a network. Okay, so we have 3 pillars of a zero trust. Okay, we have workforce, workloads, and workplace. Okay, so zero trust for workforce. So this pillar consists of people, okay, who access work applications by using their personal or corporate managed devices. It ensures that only the right users and secure devices can access applications regardless of the location. So this is very, very important. Okay. Zero trust for workloads. So this pillar is concerned with applications that are running in the cloud, data centers, or other virtualized environment. It focuses on secure access with an API, a microservice or a container in accessing a database within an application. Okay, so the application programmable interface API, this is of course an environment that we have where you know, the application is accessing the operating system. Zero trust for workplace. So this pillar focuses on secure for all devices, including Internet of Things, okay, that connect to the enterprise network, such as user endpoints, physical or virtual servers, and so on. So this is really very, very important, zero trust security. Then we have access control models. We have a number of models. So of course, access control deals with proper, how are people supposed to access your network resources? How are they able to access your information system resources and information? Okay. So you as a security analyst, very, very important that you understand these 4 access control models. So the first one is DEC, okay? So with DEC, you can see that DEC deals with, if you are the owner of information, then you can be able to give access, okay? We also have MAC. MAC, you know, gives you access depending on the level that you have, or what is known as the security level clearance. For example, this is used in the military, where we can have top secret information. So only the people with the highest level of clearance in that organization are allowed to have access to the top secret information. Okay. We also have role-based access control. So here you are going to be given access to the information based on your role or your responsibility within the organization. This is very, very important. There is no way that each and every individual can have access to all the information in your organization. It doesn't have to be like that. And then we have ABAC, okay? So this one is going to allow you to have access to information based on certain characteristics, okay? Right, and then we have rule-based. So you are going to have access to information based on certain rules or certain conditions, okay? Time-based access control. So this is a new stuff which was added. So you see, you can have a situation whereby, you know, you do the configurations and say, after 18 hours, people are not allowed to have access to the systems, okay? Or on Saturday and Sunday, people won't be allowed to have access to the systems. So that is time-based. Okay. AAA usage and operation. So you can also implement AAA in your organization. So AAA, this is authentication, authorization, and accounting. So first of all, someone has to be authenticated with the use of maybe username or password. Okay, I talked about this already, all right? I talked about authentication factors, okay, that make sure you must recommend mount authentication factor in your organization. I talked about that. And then authorization, that is after somebody has been authenticated, he has to be authorized, meaning what is allowed to do on the system. After that, there will be accounting. That is, whatever that person has been doing will be recorded, okay? So if you have an internal threat, or if somebody has done something in your organization, you just have to go to the AAA server and you'll be able to know who did it, okay? I gave out an example of the credit card, so I won't spend time on this, okay? So this AAA can be implemented in two ways, using what is known as local authentication. What is local authentication? So we can have a PC here and the router here, okay? So the username and the password of someone who wants to access the router will be created on that very router. We call that local authentication, okay? So this is what I was saying. So this wants to have access to your corporate network via the router. So with local authentication, it means that on this router, we are going to create a local database. That is, the username and the password of this lady here will be on this router. So if the username and the password match, then that's when this lady will be allowed access to the corporate network. We also have server-based authentication. Okay, now with server-based authentication, we are supposed to have the third-party component, which is the server. So here, the username and the password of this lady will be stored on this server. So when this lady wants to have access to the network, he first of all reaches the router will send that request to the server. If the username and the password match, then that information will go to this lady here, and then the lady will be allowed access to the corporate network, okay? Now, when we're using a server, what type of technologies can we implement for AAA to work, okay? So this is where we can use either LDEP or Radius or TACAS Plus. If you remember, we, that is, you can even implement it using Active Directory or LDEP anyway. We looked at Radius and TACAS Plus, the differences. We looked at these already, so I won't look at them again. We looked at these already. Okay, all right. AAA accounting information. So, of course, with accounting, of course, we're going to have a number of logs or a number of messages which will be recorded. That is what that particular person was doing. And we have different types of accounting. There's networking accounting, which deals with networking related information. Connection accounting deals with connection related information. Exec accounting, of course, this captures the information about the user exec terminal session. Okay. Of course, when you look at the router, you find that when configuring Cisco routers or when configuring Cisco switches, they have 3 levels. Okay. The user mode, the user privilege mode, and the global configuration mode. Okay, so the exec, of course, it captures information about the user exec terminal sessions. Okay, system accounting. So this is related to what has been happening, with the system will be captured. Command accounting, what type of commands were entered, and so on and so forth. Resource accounting, it captures the start and stop record support for connections. Okay, how the user was authenticated, and so on. Okay, do we have any questions on this important topic? Access control concepts. So, as I've been saying, whatever is in this course has to be implemented. But, with years of teaching, what I've learned is that students normally, they just, memorize stuff, which is very, very bad. Because anything that you do in a Cisco course has to be implemented. And you have to implement what you have been learning in this course, at your organization. So students mostly lack, implementing. Okay. Module 21, this is cryptography. Okay. So the main objective here is to explain the public key, how it supports network security. Okay. Integrity and authenticity. All right. So cryptography, it comes from cryptology. So we have cryptology, which is the making and the breaking of codes. Okay, so on cryptology, we have cryptography. Cryptography is the making of the codes. Okay, the other word that comes from cryptology is cryptoanalysis, which is the breaking of codes. So on cryptology, we have got 2 professionals, cryptographers and cryptoanalysts. Okay. Securing communication. So we have got 4 elements of secure communication. Okay. Data integrity. So this guarantees that the message was not altered, like what I said earlier. Okay. So here, for data integrity, you can either use MD5, but MD5 was cracked. You can either use SHA-1. SHA-1 was cracked. So you'll be safe using SHA-2 and SHA-3. Okay. Then we have origin authentication, which guarantees that the message is not a forgery or does actually come from whom it states. Okay. So for open authentication, we can use hash-based message authentication protocol. Okay. So here, the only difference between SHA-2 or SHA with HMAC is that HMAC includes the use of a key. Okay. Data confidentiality. So this guarantees that only authorized users can read can read the message. Okay. Data non-repudiation. So here, when somebody has sent you something, he won't be able to refuse, saying that he's the one who sent, the information. Okay. Hashing function. So I did explain about hashing. So with hashing, you have to get the message and pass that message through the hash function. And what will be generated will be this value, the fixed value. So this is what is called the hash. Others call it, message digest. Others just call it digest. Others call it the digital fingerprint. Okay. All right. So I did explain on hashing that. Let me just see. Okay. Let me just see. Let me just come here. So this is the hashing function. Okay. So the input has to be a fixed. It can be of any length, but the output has to be of a fixed length. Okay. So you can see that this is easy to compute for any given value of x. But this is one way. You can't reverse. And of course, this function is collision free, meaning that in this message, when you just add even a period, this will change the hash value. Okay, that is the meaning of collision free, meaning that if you have different inputs, those are supposed to generate different output. You can't reverse this. For example, if we have the ground nut, and we decide to pound that ground nut, okay? For you to get those pieces of ground nut, and putting them together, it is impossible. That's the meaning of this one is not, this function is not reversible. Okay, all right. So the thing is, if Alice is sending 100 kwacha to Jeremy. So you see, this is the hash value, all right? There's no way that on the way, this 100 kwacha can change to, this $100 can change to $1,000. And if it changes, of course, it has to generate a different hash value. Okay. All right. So you can see MD, of course, was developed by Ron Ravest. Okay. This is a one-way function that produces a 128-bit hash message. Okay. So this is not recommended for you to use. As I said, it was cracked. So you can see what is recommended is SHA-2 and SHA-3. Then, there was SHA-1, which was also cracked. It was developed by NSA. Okay. Then NSA also developed SHA-2. So with SHA-2, we have SHA-224. So this deals with the number of bits. 256, 384, and 512. Okay. Then, of course, there is SHA-3. So this is the newest hashing algorithm, which was, introduced by NIST as an alternative to the SHA-2 family. Okay. All right. Open authentication. Okay. So to add original authentication and integrity assurance, we have to use a keyed hash message authentication code. I did explain here. So the only difference between SHA and HMAC is that on the HMAC, we're supposed to add the secret what? The secret key, okay? All right. All right, so this is it. As I said, you see, you remember this. So this is what we use for SHA and MD5. But have you seen, for HMAC, we need to add the secret key, okay, to make this process to be as secure as possible, okay? Okay, confidentiality. So with data confidentiality, we have two encryption methods that we use, asymmetric and symmetric, okay? Symmetric uses the same key to encrypt and decrypt information. And examples of asymmetric encryption that we have are DES, triple DES, AES, okay? DES was cracked, so you don't have to use DES. And they came up with triple DES, where they have to encrypt 3 times. Even though they did that, triple DES is still weak. The algorithm which is recommended now is AES, okay? Asymmetric algorithm, this one uses 2 separate keys. It uses a public key and a private key. So the public key can be given to anyone, but the private key has to be kept secret. So examples of asymmetric algorithms that are there are RSA, okay, RSA, GSA, okay, all right. So you can see here, this is symmetric, uses the same key, the key length from 40 bits up to 256 bits. So this is faster than asymmetric encryption, and it is commonly used for encrypting bulky data, okay? Asymmetric encryption uses different keys. So this is the key length. You can see this is very, very long, okay? Asymmetric is slower, and it is commonly used for quick data transactions, okay? So as I was saying, with symmetric, we use the same key and we need to share this key. It's a pre-shared key. So we use this, the same key to encrypt and the same key to decrypt. Okay. All right. So, and of course, when it comes to CPU usage, it is not much when we're dealing with symmetric encryption. We also looked at, the key size. Okay. So this symmetric encryption can either use what is known as the block cipher or the stream cipher. So with the block cipher, what normally happens is that we can get 64 bits, we encrypt them. And then we get the next 64 bits, we encrypt them, and so on. So AES is an example of asymmetric encryption, which uses the block cipher. Excuse me. And then stream cipher. With stream cipher, what normally happens is we encrypt bit after bit. Okay, and because of that, you find that it is faster than the block cipher. Okay, and examples where stream cipher is used in RC4, A5, as well as for encrypting in GSM cell phone communication. Okay, so these are examples of symmetric encryption. So you can see triple DES. I talked about these, AES, where we have got different types, 128 bits, 192 bits, or 256 bits. So these are the sizes of the keys. It is measured in terms of the bits. The longer the key, the better. So the longer the key, the difficult it will become for the attackers to guess the key that is being used. Okay. So the other algorithm which is there is SEAL, which uses 168 bit key, and then we have Raves ciphers, which they are a number of them. Of course, they were developed by Ron Ravest. Okay. With asymmetric, we use two different keys. Okay. So we have the public key. So we have the public key and the private key. Both of them, they can be used for encryption. And then for decryption, again, we can use both of them anyway. It depends on the situation. Okay. All right. So these are examples of protocols that uses asymmetric encryption. IKE, IKE is the one which is used in IPsec VPNs, to secure VPNs. Okay. And then we have secure socket layer, SSL. Okay, so this is the one which is used to secure, traffic. For example, HTTPS. Okay, so the thing is, though they normally say SSL, but the one which they use now is TSL. Okay, secure shell. That is, if you want to manage a device at a distance securely, we normally use secure shell. Okay, and then we have the pretty good privacy. Okay, so the computer program provides cryptographic privacy and authentication. Of course, this one is used to secure emails. Okay, so these are examples of asymmetric encryption. DH, so of course, DH, Diffie-Hellman. So this one is used when you want to exchange the keys securely. And then we have the DSS. Okay, so the DSA, of course, this one is used for making digital signatures. The same applies to the RSA. Okay. Then other examples, Elgamon. So this is the key length. Okay. So you can see this is also a symmetric key, encryption for public key cryptography, which is also based on the DH key agreement. And then we have the electric cave technique. So this is also the algorithm which is used, let's say, mostly on small devices. Okay. So with asymmetric encryption, how do we achieve confidentiality? Here we can achieve confidentiality. That is, if we are going to encrypt the information with the public key, okay, and decrypt that information with the private key. Okay, so you see, it is me and you who wants to, share the information. So what is going to happen is that I'm going to share with you the public key. So when you want to send me something, what you're going to do is to encrypt that information with my public key, since I gave you the key. Then me, when I receive that information, I'm going to decrypt the information with my private key, right? So my private key, I don't give it to anyone. Okay, so this is what is being explained here. Okay, now with asymmetric encryption, how do we achieve authentication? So in this case, when you want to send something to me, you are going to encrypt that information with your private key. Okay. Now, me, when I do receive that information, already you gave me your public key. So I'm going to decrypt that information with your public key. How do we achieve authentication here? We're going to achieve authentication because we know that it is only you having that key. I'm going to be definitely sure, okay, that that message came from you because it is only you having that particular private key, okay? So this is what, is being explained here, what I've just explained, okay? And how do we achieve integrity? So we can achieve integrity if we're going to combine those two processes that we have seen. That is, if we're going to combine confidentiality and authentication, when you combine these two processes that you saw, then we're going to achieve integrity. Okay, so this is what is being explained, what I've explained. Okay. All right. So the DH, of course, this is the method that we can use to exchange the key. And of course, how things work, for you to easily understand, was explained with the use of colors. So you and me, we are going to agree on a certain color. Then we are going to add the secret colors. So this is what we're going to have. And then we're going to exchange. Afterwards, we're going to add our previous secret colors. And then this is what is going to be the final color. So you can see that this is the same. So this is mathematically, this is how DH works. Okay. So you can see that DH also comes with different groups, and these groups differs according to the number of bytes that have been, added. Okay, so that is that on the public key cryptography. And of course, today we are going to end. Here. So when I see you next week, Monday, we are going to do the hands-on lab. Good night.